Morning. My name is Wonbok Lee, and I'm a PhD student from Seoul National University of Science and Technology. Today, I will brief you on my research subject and IFC schema extension of Korean design standards for bridges. Yeah. In this presentation, I will present first the need for digitalization of construction standards, and then I introduce development of extended IFC schema and extension model. In Korea, our public project deliverables are required to comply with Korean construction standards, as shown in the figure. The current process involve living text-based construction standards and so using Excel, and the user manually check for relevant standards and apply the verify compliance, and then apply the results to the BIM deliverables. As such, text-based construction standards have several limitations. Okay, first, it is difficult to reference and apply appropriate standards. And second, there is lack of consistency in application results. Third, it is hard to respond to design changes and revision of standards. Due to this limitation, applying automation technologies such as automated code checking becomes difficult. So Ministry of Land, Infrastructure and Transport is promoting the digitalization of construction standards for BIM adoption. Additionally, in Korea, BIM deliverables are required to be submitted in IFC format. So, however, standard IFC schema is insufficient for Korean project application, especially for construction standard. As a result, IFC schema extension is needed to support ACC application. To overcome these limitations, our national project for digitalization and ACC application of Korean construction standards has been underway. The workflow involves digitalizing text-based construction standards and developing an ontology for ACC and extending the information into IFC Physical File. In this presentation, I will focus on how the construction standards information is extended into the BIM model to support ACC implementation. So we develop an extended IFC schema IFC-KR and extension module IFC-KR Toolkit to support BIM-based ACC. Although the actual project covers 7 facility types, in this presentation, I'll focus on bridge, which are the most representative facility in the infrastructure domain. Okay, this slide is extended IFC schema IFC-KR. IFC-KR extension, IFC-KR has 3 tiers to map BIM elements with corresponding Korea construction standard, such as KDS Korean Design Standards and KCS Korean Construction Specifications. This presentation focuses on KDS. First, tier 1 is object type. Object type is defined element type based on facility and structural type. And tier 2 is KDS mapping, is define KDS code by element type. And tier 3 is define detailed information required for each construction standards. And IFC-KR inserts digitalized construction standards information into IFC file based on IFC schema. There are two common approaches to IFC schema extension. First, entity extension define new entities to represent elements and processes within existing IFC schema. Second, property extension define new subtypes, properties, attributes to extend the information in existing entities. This study adopted property extension approach to ensure high scalability without modifying the IFC schema. And this slide example information extension for a continuous slab using IFC-KR. The element type is defined as IFC slab entity, and the element subtype is continuous slab is user defined because continuous slab is not predefined in the standard IFC schema. So we defined as new user defined subtype. And the related variables for construction standard are defined using IFC property entity. And the corresponding construction standards item is defined using IFC property set. Next is extension module IFC-KR Toolkit. IFC-KR Toolkit developed to insert construction standards information into IPF based on IFC-KR. It is provided as an add-in module within the IFC, open source IFC viewer, KBIM-SS Lite. And IFC-KR developed the step-by-step insertion of entities, subtypes, and digital construction standards data as defined in IFC-KR. This is process of extended construction standards information. First, select bridge type and structural composition and detailed element types. Next, insert construction standards information and the review items. And the validation of extension research. We validated syntactic of extended IPF. So we, using system by BSI, we confirm compliance with step syntax and IFC schema. As a result, we confirmed correctly applied without any syntactic issues in IPF. And we also validated data integration and interoperability. First, using IFC-KR Toolkit, we extended KDS properties into IPF elements and confirmed that ACC was successfully executed. And we also tested interoperability by opening BIM software, opening extended IPF in BIM softwares such as BIM Vision and Solibri. We verified that IFC properties were displayed without any data rows or formatting issues. Okay, lastly, conclusion. We developed an extended IFC schema and a module to integrate current construction standards into IPF. And by extending construction standards data as property set, we achieve interoperability with IFC viewers. And extended IPF was successfully validated in terms of syntax, data integration, and interoperability. This study established the specialized and extended IP schema tailored to Korean construction standards. Further research is required to enhance computational efficiency and ensure compatibility with future updates to the IFC schema version. And lastly, talk about enhance computational efficiency. As LOD increase, IFC file larger and slower to process. So we to enhance efficiency, we plan to apply the model lightweighting techniques such as fragments by that often. Okay, that concludes our presentation. Thank you for listening.